Welcome to the video session of 46 in network security. So in this session we are going to discuss about a digital signature. So we can recap cryptographic hash functions, and the learning objective of this session is is to get familiar with the digital signature process, understanding the process of digital signature, able to differentiate between conventional and digital signature. What are the prerequisites for this session is a detailed knowledge on asymmetric cryptography and uses of hash function. So now you see the introduction for a digital signature. A digital signature is a mathematical technique used to validate the authenticity and integrity of a message, software or digital document. It is a digital equivalent of an handwritten signature or stamped seal, but it offers far more inherent security. A digital signature is intended to solve the problem of tampering and impressions in digital communication. Digital signatures can provide evidence of origin, identity, and status of electronic documents, transactions, or digital messages. Signers can also use them to acknowledge informed consent. So, comparison, that is conventional signature as well as comparison with the digital signature. So first one is inclusion. So included in the document as a part of the document, that's in a conventional signature, and in the digital signature send the signature as a separate document. And second one is verification method is different. In conventional signature is recipient compares the signature on the document with the signature on file, but in the digital signature the recipient receives the message and the signature. The recipient needs to apply a verification technique to the combination of the message and the signature to verify the authenticity. And third one is relationship. In the conventional signature, normally a one to many relationship between a signature and documents, but in digital signature, one to one relationship between a signature and a message. And duplicity. In the conventional signature, a copy of the signed document can be distinguished from the original one on file, but in the digital signature, no such distinction unless there is a factor of time on the document. How it is going to be processed? The digital signature are based on public key cryptography, also known as asymmetric cryptography. Using a public key algorithm such as RSA, that is Reward, Shamer, Edelman, two keys are generated, creating a mathematically linked pair of keys, one positive and one private and one public. Digital signatures work through public key cryptographies, two mutually authenticating cryptographic keys. The individual who creates the digital signature uses a private key to encrypt signature related data, while the only way to decrypt the data is with the signer's public key. If the recipient cannot open the document with the signer's public key, that's a sign there is a problem with the document or the signature. This is how digital signature is authenticated. Digital signature technology requires all parties trust that the individual creating the signature has kept the private key secret. If someone else has access to the private signing key, the party could create fraudulent digital signatures in the name of private key holder. The following points explain the entire process in detail. Each person adopting the scheme has a public private key pair. Generally, the key pairs used to encryption or decryption and signing or verifying are different. The private key used for signing is referred to as the signature key and the public key as a verification key. And next, the signer feeds data to the hash function and generates hash of data. Hash value and signature key are then fed to the signature algorithm, which produces the digital signature on given hash. Signature is appended to the data and then both are sent to the verifier. Verifier feeds the digital signature and the verification key into the verification algorithm The verification algorithm gives some value as output. Verifier also runs some hash function on received data to generate hash value. For verification, this hash value and output of verification algorithm are compared. Based on the comparison result, verifier decides whether the digital signature is valid or not. Since the digital signature is created by a private key of signer and no more else can have this key, the signer cannot repudiate signing the data in future. It should be noticed that instead of signing data directly by signing algorithm, usually a hash of data is created. Since the hash of a data is a unique representation of data, it is sufficient to sign the hash in place of data. The most important reason of using hash instead of data directly for signing is efficiency of the scheme. So generally references are there. And multiple choice questions can be asked like this. Digital signature uses asymmetric cryptography. And in digital signature, senders use private key. Digital signature uses RSA algorithm. Yes, true. Digital signature has one-to-one relationship between message and signature. Digital signature validates message authenticity and integrity, both A and B. Thank you.